cue. Okay. Hello, everybody. How's it going? How was lunch? Good? All right. I know it gets a little heavy, and you start feeling like sleeping and taking a nap. But hopefully, this will be an entertaining session. If you like indexing, we'll go through this. A lot of details again. I'll pop into demos and give you a little bit of a quick peek at what we've actually done with the product. And I'll ask that you save your questions to the end, so we can kind of cut through this, and I can see my last slide, and then we can talk. First, my name is Cihan Biyikoglu. I'm a product manager at Couchbase. I work on the server product. If you weren't on my previous session, I'll just repeat that I'm a database geek. I've done this a couple of times. I always like to do this, Paul. I don't know why. I worked on Informix and Illustra. How many people remember those? All right, a few. It's getting fewer people. All right, SQL Server. OK. SQL Azure. OK. All right, excellent. I worked on all of those. It's not my fault that they're not as good as Couchbase. OK. All right, so let me start with the goals. I really want to give you a quick tour of this. Essentially, we'll start at the top level. Some of it, if you were in the previous kind of architecture session, I'll go through the architecture very quickly, but we'll zoom into the indexing. But this is more about the practical parts of indexing, how you interact with this thing, what kind of information you can get in and out, how to create these indexes, how to manage them, what their life cycle look like, et cetera, et cetera. So very exciting stuff. And I'll talk about an important topic, which is we've got multiple indexers. And you're going to ask yourself, which one do I use for what type of query? And we're going to try to answer that question through the talk as well. All right, towards the end, I've got some best practices, some stuff that's interesting. I assume most of you know kind of a relational database indexing set of capabilities. So I'll kind of cut through the familiar material. If things are pretty much similar or the same, I'm not going to mention them. Here's the quick overview of the agenda. We'll take a look at the top-level architecture for Couchbase 4.0. Take a look at what the current indexing capabilities provide. We'll walk through an example, and I'll try to explain why we've actually built this thing. I think this example will actually work. And then we'll deep dive into the architecture and go through some of the mechanics of how you interact with indexing through the talk. Towards the end, I'll do a Q&A. All right, it's the same picture if you were here earlier, a couple of hours ago, Couchbase Server architecture. We actually have the same node type across the cluster. At the top, the client knows about the cluster topology through something called the cluster map. At the top of the cluster, at each node, there's something called a cluster manager. It's the governor for the entire cluster. It actually orchestrates what we do across nodes, their health, their rebalance, failover, all the type of things, your membership to the cluster. All of that is governed through the cluster manager. Data service is responsible mainly for the KV operations. It actually still continues to hold. Data service is very much what you actually had in 3.0 version of the product. It continues to do the same set of things that data manager, which used to be the box, does, but it continues to manage the views. So it's fairly familiar, but there are two new services. One of them is indexing. The index service, again, you can enable this on all the nodes. The index service is responsible for global secondary indexes. This is the new indexing that we're actually introducing in this release. And the query service is the Nickel execution engine. It is also brand new. The nice thing about these things is that you can either enable all of these services on all the nodes. Most people will probably start that way. But you can turn them off. At some point, you can actually go and say, this part of my cluster, this zone within my cluster is actually going to run the data service. And this other zone is going to be about my indexing operations. And this other zone is going to be query processing. Why would you do that? Well, it actually is interesting because when you put them together, these guys actually compete with each other. So the faster you insert, the faster we have to maintain the indexes, or the more work there is for us to catch up with. And as the queries come in, they're actually kind of interacting with the data as well. So that competition kind of hinders certain things. And it turns out when you actually scale out, picking a single type of hardware that essentially kind of satisfies all of these different type of workloads, what they actually do with indexing versus queries versus data is very different. And as you add more nodes and kind of homogeneously, mindlessly kind of push an equal slice of the workload to a new node, it doesn't actually improve everything the same way when it comes to indexing or query. Now, the data service loves this, but indexing and query are actually quite different. So that's why we actually wanted to do them independent, and we wanted to give you the option to be independently scaling with those, so you can choose different hardware for them. Anyway, there's a talk about multidimensional scalability tomorrow that Anil will do. I highly recommend going to that if you want to kind of understand a little more of the why we actually came up with MDS. Very, very unique capability. Let me focus back on indexing. So this version of the product, we're actually going to give you more indexers. We actually have 2 more. One of them has been experimental in there, but incremental MapReduce, that's been there for a while. We're now adding a second one called spatial indexer. This indexer actually works pretty similar to the view engine, but it does build an R tree that allows you to ask bounding box type of questions to this index. It's a geospatial index. And the new one that is at the top is global secondary indexing. It's the unique new indexing capability that we've added. As I said in the beginning, you'll ask yourself, all right, which one do I use for what? I mean, spatial is kind of obvious, but the other two, they're a little interesting. So let me walk you through an example. The example is, let's assume this is a user profile system, and once upon a time, you were actually asking this question. I want to find out the most monthly active users, or the top 10 most active users for the month of January in 2015. And it turns out my document actually is configured fairly nicely and friendly to this kind of question. I have something called total logins within my document that actually keeps track of per month how many logins everybody did. Well, it's kind of a simpler question, but let's find out what happens today in many of the products and with Couchbase views when we try to execute a question like this. So this is what happens. You actually create an index on this field. It's not surprising you will do that. Then you actually ask this SQL statement to the query engine. You say, all right, I actually want from the customer bucket this information about the top 10 most active users. What we'll do first is we'll receive that on one of the nodes that we actually have. So we'll go, yeah, all right, thank you. Let me ask every node who the top 10 active user is for the month of January. Because my data is not on a single node. My data happens to be scattered to all of these nodes. They actually know about parts of the data. They're kind of hash partitions. So not one of these guys will actually know the answer, but they're all going to have their own top 10 list for the active users. So I'm going to have to scatter. What happens next is I'm going to have to gather those results. So if I have 50 nodes, there's 50 results I gotta scatter, and 50 results I gotta gather back. And next, I have to kind of finalize this execution by executing essentially a final query that will get me the result of and eliminate the 50 result sets I got from the 50 nodes I was processing. So that is the final phase of the query. Once I actually understand the top 10 the user is interested in, not 500, but the top 10, I'm actually going to hand it back to the client. So that's the execution path. That's what we do. But you can see why it becomes kind of interesting with the independent scalability of the services and with GSI. Because this is what will happen with the GSI index. We will receive this nickel query on the nickel node. That's going to be, let's assume that from this picture, I know you can't see that, but that node that actually has the arrow stabbing it, it's the query service node. That node will receive it, and it will say, all right, I know an index that actually lives on this next node that knows the answer. It has the total logins, and it's actually running on a single node. I don't have to scatter and gather, but I have to go to that node, and the index node happens to be containing that index fully. I actually get the answer of top 10. I return it back, and the query is done. So the idea is that we can do a lot more local processing for a question like this. Scatter-gather could give you parallelism, and all of these nodes can actually process things in parallel, but the network is not very fast. And the wider our fan-out has to be, the slower sometimes some of these questions will actually get. And views suffer from this, and many of the other products suffer from this. But if you can contain your index in a manner that is not a partition aligned to data, data can live in whatever partitioning model it needs to live in. But if your indexes can independently partition and can give you the answer from a single node, then that becomes very interesting. And that's why GSI does. GSI essentially gives you this capability to limit the scatter-gather that you have to do, and that makes it extremely efficient. It's fully integrated into Nickel. It independently scales. It can be distributed separately from the data, and it runs on top of ForestDB, which is a new powerful storage and caching engine for us. So with all of these things, it makes itself unique. But I know you're still asking this question about, all right, I understand, but views versus GSI, so tell me more. So I'll try to do this in 2 slides. First one, we're actually going to look at some workloads. These are some of the type of workloads that you may actually run, and I'll try to tell you what happens with each. GSI is the first column, views are the second column. So let's start with complex reporting. Actually, it turns out views still have a bit of an advantage here. One of the things that views do is they actually take in JavaScript for a map and reduce, and they will pre-compute the result and store it. So when you ask some aggregation, we actually don't have to think hard. We can tell you what we've wrote already processed out of the view. So if you're looking for some complex pre-aggregated, pre-stored answer, some complex reporting logic, it actually turns out views can actually be helpful. They're actually optimized for different workloads. So when you look at GSI, it is actually optimized for the scan latency. It is optimized for the secondary lookup. It really can do that very efficiently because it doesn't have to do the scatter-gather. But if you look at map-reduce views, they are partition aligned the way they're distributed to the data. So it can locally process without having to leave the node for all the updates that are happening to the vbuckets. It can locally process the index. But when it comes to answering questions, it pretty much always has to scatter and gather. The wider the fan out, the harder it gets. If you're looking for flexible indexing logic, now views can actually be interesting. Nickel functions, there's a wide variety. Gerald talked about them in the previous session. Keshav will talk about them, I'm sure, even more in upcoming sessions. But Nickel functions provide that capability, but it is just-in-time processing for the most part if you actually write a group by statement. Or if you define a complex aggregation, you actually do this in runtime. But if you're looking for very complicated logic, the JavaScript language gives you a lot of power to do a lot of manipulation. You can emit multiple results out of a single map. So there's some differences there. Secondary lookup, this is the case where GSI really just heads down wins. It's ultimately the best type of index to do. And when it comes to tunable consistency, GSI actually has an advantage. I'll touch on this point in a little bit, so I'm going to skip over that. Second slide I want to show you is about the capabilities of the two. This is a little more, not the workload, but what it actually kind of does when it comes to GSI versus views. How do we actually differentiate? And partitioning model is the most important one at the top. So again, I've repeated this a couple of times, but views are partition aligned to data. So if you've got 50 data nodes, you're going to get 50 partitions of the view that are kind of aligned to each partition of the data service node. Versus GSI is actually something that you can independently scale and partition. Scale model is different. You can take the indexes, put them in a separate service. The GSI indexes on a separate service, and you can actually disable them on specific nodes, give them dedicated compute capacity that's without any competition from the other services. If you're doing something like fetch with an index key, let's say you've got email address that you're looking up. Your document key happens to be something else, but you want to look up people by email. GSI actually can do that through a single node lookup, versus a view query, just like the one example that I showed you, has to do a wide scatter-gather to actually figure out whether this index, this email address exists or not, right? Because the hash partitioning doesn't tell us anything about, it's not a partition on that field, so we have to go ask every node. Range scan, very similar. When it comes to grouping and aggregations, Nickel can actually do them. You can write a reducer in the view case to be able to pre-compute that. When it comes to caching, because of ForestDB and because of the latest technology inside GSI, it does a better job of managing cache. Caching of the indexes versus views are not up to date in some of the caching they actually do. Storage is different, CouchStore versus ForestDB. If you want to know why ForestDB keeps coming up as some big advantage, you should go listen to Cihan, because there's a whole bunch of interesting capabilities that come with ForestDB. One of them is the fact that the tree is going to be much shallower. If you're familiar with the B-tree structure, and when the index keys get much larger and larger, the depth of the B-tree index gets pretty tough to tackle. Versus in the case of ForestDB, it is actually built for very large keys. So if you end up putting the email address plus the customer's address inside a single index and their country and location and everything else, we'll actually have much better experience in terms of write amplification, in terms of access paths, much better experience with ForestDB. And when it comes to caching, it actually does much better. And when it comes to availability, views actually have a slight advantage in Couchbase Server 4.0. They have replicas. In the case of views, I'll talk about this. In the case of GSI, you actually have to manage this manually. So I'm sure this question will continue to come, but let me just deep dive into some of the other things about GSI. So this is the architecture, and this is how GSI and the index service essentially interacts with the rest of the cluster. At the data service, we get a DCP stream. These DCP streams give us all the changes that are happening on a bucket. Per bucket, we get that stream. There's something called projector and router that sits on that node. The projector and router's responsibility is to take the change, and the change actually will give you the full document, the new document, that is the new image of that document. May have been an update to just one attribute, but it will actually give you the full document. So the projector and router's responsibility is to take that update and to boil it down to the relevant pieces of information that the indexes need. It knows about the index metadata. It knows what type of indexes I have, which buckets I've indexed. And it will only put things on the wire that are relevant to the indexes that I have. So it's efficiency in building and maintaining the index, and that's what it's trying to do. When it gets to the supervisor, which is the component that is responsible for running the indexing service, the indexing supervisor is essentially responsible for both maintaining the indexes that are local to it, and per node you are going to get a supervisor. So if you've got 5 nodes of indexes, index service, you are going to get 5 supervisors, one for each node. And on each node you can have any number of indexes that it maintains. But the supervisor, just that one supervisor, will maintain all the indexes that are local to it. And it's also responsible for answering Nickel when it comes with a scan request, and it will have to respond to those. There's a lot of details here that I'm leaving out. I'm oversimplifying this. There's a talk that John will do. I highly recommend that you guys stick around and watch this after that, or see it if you're not online. So this talk will happen at 3:45, and I highly recommend it. It's today. Let's talk about the lifecycle. So this is where kind of the architecture stuff ends, and we'll get a little more hands-on. All right, so this is how you create these guys. There are 2 types of indexes. Indexers are separate concepts. Those are the views versus GSI. But when it comes to indexes, there are 2 types of indexes Nickel can create. One of them is called a primary index. Primary index essentially is an index that contains every document key inside a bucket. It doesn't filter, so there's no work clause at the top, as you'll see. You can use views or GSI as your indexer for that. For GSI, you get a few other options, like defer builds and specifying the nodes. We'll actually touch on those a little bit. You give indexes a name. That's not very surprising. You have to tell us which bucket to index. That's not very surprising, but this is kind of the format of it. And when it comes to secondary indexes, you can actually create secondary indexes that are filtered. And that means that you can actually say, instead of, in my bucket, if I have beers and breweries, I can actually create an index on beers. And I can specify that in the work clause, or whatever other thing you actually want to specify. We also support compound indexes, so you can actually put multiple columns inside the index and index those things. You can specify functions, nickel functions inside there, and if you're using them, we'll actually use and compute the index through the function. So you can have an array in your document, and you can say, I want to sort this array and then index it. And that's perfectly legitimate to do. Again, GSI gets kind of extra options like deferred builds and nodes. But that's what it is. There's one interesting option that we provide to you when it comes to the build time. And what this is essentially deferred building. It was one of the options in the previous slide if you were paying attention. But it essentially allows us to do this one thing. If you kick off many create index statements all at once, which is very typical. When you're setting up your application, you're going to create 5 indexes, 15 indexes, whatever. You actually kick them one at a time. The problem is, now we're actually reading a lot of information for each index on separate set of DCP streams. Instead, what you can do is you can defer the builds for these indexes, and you can say, let me just pause them. I want to create these indexes, but let me pause right as the task for indexing gets queued. Let me pause it right there. And what I'll do is, in a single scan, I'm going to build all of these indexes all at once. And this is called deferred building. And the build index statement is built exactly to kick off the second phase of the build operation. So I may have 15 indexes that I built, that I paused. And then I can specify build index. And that's going to kick off the building of the 5 indexes all at once. But the optimization here is that I'm going to do one scan of the entire bucket and not have to do 5 separate scans of the entire bucket. And that gives you an efficient way to build indexes. And because we're big data, we kind of expect a lot of volume. These type of things actually matter. So let me give you a quick tour. This is what we were looking at. All right, so this should look familiar. Let me just make this a little smaller so you can see. This is the beta 1. You can go download it today. It hopefully doesn't surprise you that we have a cluster overview page. The server overview page has something interesting that I'll point out, and that is the service. So you can see that in this mode, I actually have 6 nodes. It happens so that I have 4 nodes at the top that are data service, and then the next node is index, and the node after that, the 6th node, is running the query service. So I've got this isolated deployment that I've created. When I want to add another node, I get this option at the bottom to be able to check everything, or I can uncheck specific things. On the buckets, there isn't really a whole lot to show, but there's this one new tab that you will see at the top that shows you all the indexes. I know this is a little small, so let me just make this bigger. But the default bucket, it gives you the bucket name. This happens to be the primary key, so you can expand and see the primary key definition, and you can see the indexes. We're kind of showing you some basic information about what these indexes can do. Now, the way you can interact with them is fairly simple as well. Let's create an index. I hope you guys at the very back can actually see this, but I'll read it out loud too. So this says select star from default. Default happens to be a bucket, and I'm going to limit 1 just to get you one row out of the database, just to show you what the documents look like. I have one type of document. It's fairly simple. It's got this friends sub-document in it. And it's got an array called tags. And why don't we do create index ifriends 1 on default. And then we'll actually take friends. We'll take that sub-document and we'll index the sub-document. So this is what you type in. You say using GSI. And if demo gods are with us, it will take 11 seconds and come back with an index. While this is happening, let me go back to here and show you with a refresh that there is ifriends. Let me see if I can find it right here. It's actually building it. It's at 0%, so it may take a while. You can actually see it kind of building. Hopefully it's complete by now. Yes, it is. And I can just do select star from system indexes and see that I now have a new index called ifriends1. This is pretty much it. it's fairly simple to interact with. It's fairly intuitive to work with this thing. So quick tour, but let me dive a little deeper. So one interesting question that comes up all the time is obviously these indexes can get large because I've got a data service that may be 50 nodes or 20 nodes or 30 nodes and terabytes of data. How am I going to fit that one index into the index service? I've got a lot of options. I can actually have multiple nodes of index service. What is the way I actually place and partition these things? So one of the things you actually need to know is that you can control the placement of the index very precisely by specifying the name of the node. The nodes clause let you do that. Now, an important thing to remember is every create index statement actually creates an index that resides on a single node. This is something that will start within 4.0. It will change in future, but it is something you should understand. And we actually also let you do something that you probably weren't allowed to do in some other environments. We will let you create identical indexes. Because we have multiple nodes, it turns out it actually is a great thing to be able to do that, because if you have the identical index in multiple nodes, what we can do is load balance across them. And we can answer your scan requests when you place them on separate nodes or even on a single node that actually has a lot of cores. We may be able to scale out the processing of that index. So there's these kind of manual tricks that you can play to get better throughput as you work with indexes. There's also manual partition capability available. This is the where clause that we looked at. So I can say, well, by the way, I'm going to index the zip codes, and I am actually going to take these subset of zip codes and put it on node 1. I'm going to take these other subset of zip codes and put it on node 2. And when I actually run my query, if my queries happen to be hitting a variety of different partitions, I can utilize multiple nodes to be able to answer the question. I can get you more throughput by scaling them out. This is still manual in 4.0. In future, that will change. GSI's availability and rebalance is kind of an interesting thing as well. How do I actually kind of fail a node or add another index service node? And what happens when I push that rebalance button that I like so much? And what you can do is, as I said, you can create multiple indexes that are identical and place them on separate nodes. And that becomes your availability story. This is a bit of a manual approach. Obviously, the replicas and the placement of replicas in the data service was something that was automated, and we'll get there too. But in this initial release, you essentially need to create manually a set of indexes that are identical and place them on separate nodes. You need to make sure that before you push the rebalance button to rebalance out a node, the indexes on that node exist on someplace else. Otherwise, we're actually going to drop that node. It's no longer going to be available to Nickel, so you may lose the indexes on that node. But index building operation is online. You can certainly put these indexes on another node before you actually push the rebalance. It's just a couple of additional steps you need to understand. The rebalance, failover, and some of these verbs you're used to from the previous versions of the product, they still continue to apply to nodes. You can't fail over an individual service. You can't fail over the index service just by itself. You still have to fail over the node. But when you're doing things like swap rebalances, et cetera, those verbs still work, and you can actually have an extra node that you're bringing in while you're taking things out. And the things you know and the way it works for rebalance with the data service continue to work this way. You just need to know some special things about the indexing service. So just be aware, when you rebalance something out, we actually drop that node. There are no replicas we maintain, thus there's nothing for us to rebalance. So whatever you're taking out will actually leave the cluster. When you bring a new node in, we're not going to place anything on it. There's no rebalance action that we take. There's no replicas that we place. So these are all things that you have to do manually in the first release. When it comes to monitoring, we actually have pretty straightforward set of capabilities. There's two sets of stats. If you want to monitor the index maintenance, there's a lot of counters that will actually tell you how many items we've actually scanned and how many of them have we committed. What are the number of items that are pending, not indexed yet? And all of that, or the index size, for example, are things that you can actually grasp out of the statistics page fairly easily. When it comes to index scan statistics, there's a whole bunch of other counters that you can work with too. You can see the bytes returned per scan. You can see the average scan latency and get some aggregate results at the top. There's there's a good set of capabilities. This is, I don't know if everybody knows where to get to these, but you go to the bucket. It's the same place. You click on the bucket itself, and you will see, just like views, expanded list per index that will, sorry about that, that will be down here, that will give you per index statistics. So just so you know. Now, in this section, in this last couple of minutes, I want to tell you a couple of things that are very unique about GSIs. And these are the best practices for GSI. So the first one is, when you're developing applications, there's one thing you need to remember about consistency. I mentioned this briefly in the beginning of the talk, but with views, it actually turns out we gave you 2 staleness levels. There was this update after thing, but that's kind of has a different purpose. So views, you could actually ask 2 type of consistency levels. You could say unbounded, I'm stale equals OK. I don't care. Just give me whatever you index when I query. I just want to know the result as quickly as possible. I don't care about consistency, and that was stale equals OK. Stale equals false meant at the time of the request, you capture that timestamp, and you wait until all the operations in the KV nodes that happen up to that request timestamp is indexed before you start running the index operation, index scan operation. So that meant that you were absolutely consistent. It's kind of similar to the level of consistency you might expect from a strictly consistent relational database. The index contains what you just saw in your previous calls, et cetera. But it essentially was these 2 levels. There wasn't anything in between. Now, in this next version, we're actually giving you something that is much more flexible. And let me explain it with an example. So let's start at T1. T1 happens to be an operation that actually inserts a key 1 and a value 1 into the data service. So at T1, I actually happen to have this. And I have some other business logic during T2 that I'll actually run. But at T3, I decide I'm going to issue a query. Now, I'd like to be able to see what happened in T1. My option with views would be, I will say stale equals false, and that's the only way I'm going to get guaranteed to see the operation I just did at T1. With global secondary indexes, you can specify T1 as your consistency level, and don't have to wait for the indexing of the 10 milliseconds worth of operations that happened between T1 and T3. We can actually do a lot of work in 10 milliseconds in Couchbase. I don't know if you've seen some of the benchmarks, but it could be hundreds of thousands of operations. So having this kind of flexibility, it actually reflects back into the query latencies that you will experience when you issue this type of query. So instead of saying T3, if I could actually say, I'd like to select this from this bucket and use this index, but I'd like to use the consistency flag of that, the consistency timestamp of T1, I can actually get a much lower latency experience when I interact with that query because I don't have to wait for the indexes to catch up to T3. So that's one important thing to note. And only GSI can actually do this. When you issue something like this to views, you're actually going to get stale equals false semantics, so you're not going to get a better performance. Another important thing is to know about kind of complex types. Obviously, rows and columns, relational databases, I'm not going to talk about every attribute you can kind of go index on. But there are some attributes that are very different in our case. We're a JSON-based document database, and we could have sub-documents in there. So it turns out this document actually has friends on the right as a sub-document. Friends actually contain an ID and a class. In this case, I have one option. I could actually go index friends.friendID. I could create an index on that, and when I actually run a statement like select star from blah, where friends.id equals something, I'm actually going to get to use that index. So you can traverse these trees, and this is fairly obvious. But there's some other interesting options that you can play with. So it turns out we can actually give you the option to say friends.id and friends.class as well. You can create a compound index on this thing. You can actually put all of them together. And when you ask questions like friends.id equals something and friends.class equals something, we can actually use that index as well. So this is another option for you to work with sub-documents, which is kind of an interesting type. But this traversal is possible. Now, another interesting component of Nickel, and I don't know if Gerald actually showed this, is that you can query equality of documents. And even the attributes orders don't have to be exactly the same, but this is extremely powerful when it comes to nickel. So one of the indexes that I can create is actually on friends. It is the subdocument itself. It will contain multiple columns, multiple attributes, I'm sorry. And when I actually do that, I can ask questions like, where friends equals, curly brackets, and I specify the document I'm looking for. And that full document can actually be used, the index that you created can be used to search for that full document. And that's a very interesting capability as well. So these are some of the interesting components. One other thing that I'll mention before I kind of close on the best practices and recap is arrays. So it turns out this document actually has another tags field that contains an array. Arrays are kind of interesting because you can do a lot with them, and there's a lot of functions in Nickel that allow you to manipulate them. But indexing arrays can get tricky. The way in which you will index them is you can index the entire index. You can pick up the first value or the second value, etc., or you can index the entire array. Now, the problem is we actually care about the order of that array. So if it turns out that you have an array called 0, 1, 2, 3, and you search for 0, 2, 1, 3, we actually don't think that's a match. When you create the indexes, you have to pay attention to this. One way in which you could actually work around this is by sorting the indexes when you actually index them. And then when you ask array equality type questions, you actually ask it with a sorted array by using the array_sort function. So there's, this is just one example. There are many different ones, tricks and tips like this. But I just wanted to highlight the fact that you can use these functions to index and query at the same time. And matching those things are going to be possible for Nickel to optimize these queries and still use that index behind the scenes to get that. So I'm just scratching the surface of what you can do with this thing, but I know I'm going to run out of time. So hopefully you guys like this kind of quick tour of the new capabilities and the new power. It's a little more clear, at least, that the new power of the GSI is different than what Views provided, and it brings in some unique capabilities. So with that, I'll close and open it up for questions. Yeah, so will views go away, all, or will they actually live? And the answer is views will actually continue to live. As I said, there are some very unique capabilities in views. So we think that there's going to be a whole bunch of interesting things we can do with views. They're very unique in the way in which they can actually answer questions, and we'll continue to enhance them in future. Yes?
Rebalancing indexes or something like that.
Mm-hmm.
I didn't catch that.
I can repeat that. So rebalance operation, essentially there's one interesting limitation you need to remember. When you create an index, the create index statement creates an index that resides on a single node. What happens with rebalance operations, typically coupled with kind of an add or remove operation of a node, is that you're actually changing the topology of the cluster. If it turns out that you're removing an index service node that contains indexes, when we rebalance, you're used to not losing data or not losing a vbucket, right? We actually go through an operation, a long-running operation called rebalance, and we replace the vbuckets that used to be on that node that's now going to go away. We used to take them and spread them over to the existing remaining nodes. With indexes, we don't do this. We don't maintain replicas. We give you full manual power to be able to place the same index 3 times or 4 times into different type of index nodes. But when you rebalance, when you take that node out, whatever indexes were on that node are gone. Or when you add a node, when you push the rebalance button, you were used to seeing vbuckets kind of travel into this new node, and things get kind of auto-redistributed, right? That doesn't happen with the index service. Data service still does it, but the index service doesn't. And the manual workaround that we give you is you can create replicas, the identical index in multiple nodes. So when you add a node, you may actually have to go create 4 indexes instead of rebalance being a single click. You have to create these 4 indexes that now you want to move from some other node into this.
But
Correct, correct. And the identical indexes are things that we rebalance, load balance across. So if you have 5 indexes called I1, I2, I3, I5, they're all the same. We're actually, even without any type of rebalance operation, as you ask questions, we're going to load balance across them. Yes, I'll go through this way. And yes?
So let's say I have 50 nodes. I have a bucket called orders.
Okay.
Okay, so 50 million orders, 1 million on each node.
Okay.
So basically, 20 vbuckets per node. Let's go to my data distribution. So if I have 1 to 5 as query nodes and 45 to 50 my nodes as index nodes, and I create an index on, let's say, node 45.
Mm-hmm.
That means the whole of data, all those 50 million orders, the index for that will be created on only one index node. And if the query node fires a query on that particular bucket on query node 1,
Yep.
then that has to basically get the data from the index node before it gives to the query.
Correct, correct. So the only caveat I'll put into that, I guess I should repeat, but I may have a large cluster. The index gets placed on a single node. That's kind of surprising. The workaround to this is that we actually expect you to partition manually the indexes that you create with a where clause. So if the data is really, really large, and if your filter clause is not filtering down enough data, you're trying to create an index on all of your data all at once, we ask that you actually manually partition with a where clause in every index and place those indexes either on separate nodes, but you kind of spread them around. And this is the manual partitioning of the indexes that you have to kind of live with in the 4.0 time frame.
Join columns, does it have to be reading column which is used, or all columns which is used? Only then it use the index.
Sorry, you asked about join columns.
So let's say that the index on 2 columns.
Yes.
Okay. So do you have to, in a where clause, use both columns is equal to, or only the reading column will do?
Leading column will do. So the question was, can I compound index first columns be used when a query that actually just uses that? And the answer is yes. And Jody's telling me it's end. So I really appreciate it. Thank you very much. Thanks for staying.